Earlier in the year, we looked at discrete random variables, and when we did that, we talked about the two types of random variables, discrete and continuous. I mentioned continuous briefly back then, but let's look in a bit more detail. Continuous random variables represent quantities that can be measured, and thus may assume any value within a given range. We talked about discrete random variables being definite values, whereas a range of values characterise a continuous random variable. And what sort of things have a range of values? Time, 10.947 seconds. Okay, sometimes we do say 10 seconds, 11 seconds, etc. But theoretically, if we're measuring something like time or height or weight, the three I've mentioned there, they can assume any value within a given range. They're not discrete values. So that's discrete random variables. Continuous random variables. Now, when we're talking about probability of continuous random variables, we use a thing called the normal distribution, which is used a lot in statistics and probability. And the distinctive thing about the normal distribution is that it forms what's called a bell-shaped curve. And you can see that bell-shaped curve there, and in the middle of that bell-shaped curve is the mean, the mode, and the median. Let's look at the main characteristics of a normal distribution, and I've highlighted there two words, bell-shaped and symmetrical. The normal probability distribution is characterized by a bell-shaped curve that is symmetrical about the mean. Okay, and because it's symmetrical about the mean, I've got 50% each side. Now, what does that 50% mean? It means that there's a 50% chance of it being less than the mean, 50% chance of it being greater than the mean when we talk about probabilities. Okay, so I'm just giving a value for the mean for the moment, say of 10. So probability of it being greater than 10 is 50%, less than 10 is 50%. The mean, mode and median are the same, I've mentioned that. Third point here, many of the frequencies are situated near the mean. If we talked about, we talked about 10 being in the middle there a moment ago. The chance of it being, say, between 9 and 11, okay, are quite high because a lot of the area is in between those two values there, between 9 and 11. Okay, so the area of this graph is related to the probability. It's a pity we haven't done integration yet, or integral calculus, because it's sort of related to this normal distribution curve, but I'm sort of ignoring it at the moment. We might revisit it when we've done integral calculus. Okay, rid of that. Moving on. The graph extends indefinitely to the left and right of the mean and never touches or goes below the axis. I've done my best to represent that here. Not too good on the right hand side, but it does keep on going and never touches the axis. So my arrows there, right and left, demonstrate that. Okay, just another way there, looking at the symmetry, 50% either side of the mean. Now, there's some other figures other than 50% that we have to look at. And I'm going to talk in terms of probability here already. This is, as I said, these bell-shaped curves. The normal distribution is also looked at data and statistics, but I'm going to talk in terms of probability. So let's use the language here that for these probability distributions, the first one here, in any probability distribution dealing with the normal curve here, the bell-shaped curve, 68% chance of being within one standard deviation of the mean, 95% chance of being within two standard deviations of the mean, and 99.7% chance of being within three standard deviations of the mean. Now, it does go on further than that, but for the purposes of our course, we'll just leave it there at 3. Notice it's not 100%, there's still a small chance we can go even further out, left or right. But these percentages are quite important, and we're going to do some problems associated with them in just a moment. That's another way of demonstrating it. 68%, 95 and 99.7. Similar sort of deal there. That's putting it in without the diagram, just putting it in probability form here. So what this means here, that the probability of being within one standard deviation of the mean, that is the mean minus one standard deviation and the mean plus one standard deviation, is 68%. The probability of being within two standard deviations is 95%. The probability of being within three standard deviations is 99.7%. Now, in some books, you'll find, and if you Google some of this sort of stuff, that they are a little bit different. They're 68 point something. Can't remember exactly what it is. But for our purposes, we've rounded them off to the round figure there of 68, of 95, and 99.7. Okay. Let's look at a question here. Scores from a certain test are normally distributed with a mean equaling 84 there, and a standard deviation of 4. Remember, that's the symbol there for mean. At mu and rho, I think it is, equals the standard deviation. Find the percentage of scores which are between 80 and 88, 72 and 96, above 88 and above 96. All right, I'm not going to worry about the questions just to start with. We're looking at there the 84 and the 4. So what I'm going to do straight away, 84 and 4, straight away is I'm going to write here on this standard deviation, on this normal distribution curve, bell curve, that information. So 84, as soon as I see the mean is 84, I put that in the middle. And because the standard deviation is 4, I now add 4 to 84 to make 88. 88 plus 4 is 92, plus another 4 is 96. We've got 100. And the other way we subtract 4s. So you can see how I'm doing that. So that's the first thing. Make sure that you do that. First up, so I've put those figures in there. And now I can have a look at the questions. Okay, so we're looking at the percentage of scores which are between 80 and 88. Okay, so I'm looking there for, just use a red arrow here, between 80 and 88. I'm looking at between those two values there. And you can see that equates to 68% between 80 and 88. There's my 80, there's my 88, and the 68% in between those. So that's our first answer. So that's going to be 68%. Between 72 and 96. Let's locate those two values. There's 72 and there's 96. Okay, so we can see there it's 99.7% is the percentage in between those two values. So my answer is 99.7%. Next one is above 88. Okay, so this time we're looking at, if I'd use a different colour arrow here, maybe a green one, above 88, I'm looking at that there, okay, going on towards infinity, to that right hand side above 88. Alright, now this is where we have to start thinking a little bit. If we look at the percentages we've got on the left hand side of 88, that is less than 88, let's have a bit of a detailed look at that because we haven't really split up these percentages yet. So let's have a look. We've got, because it's 68%, we've actually got 34 here and 34 here. Now, if we're going out to 95 between here and here, okay, 95 minus 68 is 27%, so that's divided into 2, so we get 13.5% there and 13.5% there. Okay, we're going to further than that, 99.7% means we've got the either side, if it's 95 from there to there, looking from there to there is 99.7. That means we've got 4.7% between these two bits, and we divide that in half, we get 2.35% there and 2.35% there. What's left over? Well, 99.7% between here and here. That means outside that we've got 0.3%. So this side here we've got 0.15%, half of that. And over here, this way we've got 0.15% there. Now back to the original question, which was more than 88. So to find that now I can add, if I put a red square around it, we can add this up, plus this up, plus this up together. Okay, that's going to equal 16%. So there's 16% that are greater than 88. Now, it took me a while to get there, but I wanted to show you that even though we've got those larger percentages, 99.7 and 95, etc., we've got those other percentages when we divide up the different sections there. So the answer to that one would be 16%. Might be an easier way of working that out. You can have a look at, but anyway, that's the way I think it's best to work it out, 16%. Last question, above 96. Okay, so we're getting a busy diagram here now, so I'll use gold colour here. Above 96, we got looking at there. And that's why it was useful there to work out those other percentages, because you could quite clearly see that it's 0.15% greater than 96. So that's our answer here. 0.15%. Alright, let's move on to another question. For a normally distributed variable with mean equals 70 and standard deviation 18, find the range between which 68% of the values lie. Okay, so let's do a similar thing as last time. We've got a mean of 70. Okay, 70. And a standard deviation of 18. Okay, which is there. So we add 18, so we go 88 to there. Another 18 is 106. Another 18 is 124. Another 18 is 142. Taking away 18s, we get 52, 34, and 16. Okay, and we could go to -2 there if we wanted to. So we've got our range of values there. And the first question says the range between which 68% of the values lie. So we know 68% is that middle section here. Okay, and the answer will be between 52 and 88. That's the 68% there. So 52 to 88 is our answer. So 52 to 88. The range between which 95% of the values lie. Okay, so 95% is that range there. And that's going to be 34 through to 106 is our answer there. So there, 34 to 106. The value below which has 2.5% of all values below it. Okay, so 2.5%, remember the diagram I did before, we've got those individual probabilities, so 2.5% covers from 2 standard deviations and less than 2 standard deviations away from the mean. So it's that section there, from 2 standard deviations and below that. So if we go back to here, that's our 2.5% there. That section over there, the last, well, these 2 sections there and there. So that would be less than 34. Okay, so the value below which 2.5% has 2.5% of all values below it would be 34. Oops. Sorry. Try that again. Here we go. 34. Should have mentioned this at the start of this presentation, but a bit of terminology here. We saw before, earlier on, about x being binomially distributed, and we had terminology for that. So if x is normally distributed, this is the way we write it down. So you can see there, we've got x, little squiggly line there, like approximation sign, capital N for normal, and we've got our mean there. And this one here is the variance. So you've got to be very careful because remember when we set out our normal distribution we've got mean and standard deviations. So we've got to be careful. Just make a note of that. That is actually the variance, not the standard deviation. So be careful there. Always get the square root of that to get the variance. So here our mean would be 20 and our standard deviation would actually be 5. Okay, so if we were to put that down here, it would be 20, then going up in 5s, and going down in 5s. Alright, that's a bit of a start now to normal distribution, and you should be able to do some exercises now. Hit the book here, exercise 12E. Exercise 12E. Have a go at that. I might just nominate some questions actually from that one. Probably look at questions 8 onwards, I'd say. So question 8 onwards through to 23. Don't have to do them all, they're a bit repetitive and they're reasonably easy too, to be honest. So see how you go with that.